Saxon Algebra 1, Lesson 24. You guys, does this title look familiar? Multiplicative Property of Equality. Last time we talked about the additive property of equations. Oh, it should have been of equality, sorry. And now we're talking about multiplicative property. So we're talking about multiplying in fractions instead of just adding. So it's very similar. And I'm going to present the information to you just the same way. First, we'll look at an example, then we'll talk about theory, then we'll go back to more examples. This time, our equations look like this. 5x equals 20. Again, we notice that's an equation. There's an equal sign. We find our little x, and we need him to be by himself. We want to unravel whatever's happening to him. This time, instead of adding or subtracting numbers, we are multiplying by 5. So again, just like before, if we were adding, we subtracted, you choose the opposite operation, right? And the opposite of multiplying is dividing. So we divide both sides by 5. Hannah Cranny must be happy. And then this cancels and we get x equals 4. Notice that the way I show my work when I'm dividing in an equation, it looks a little different than the format we used for adding. So this is subtly different. This is the way I want you to do any kind of problem where you're doing division, okay? That's one of the reasons why I want you to write down everything I do in the lessons, is because I want you to get used to the way that I present the problems. Everything I do for a reason. It's not just random, and it's not just my personal preference. This is a very classic presentation of algebra, and I want you to learn it exactly the way I show you. So I am a stickler for details on this. Make sure you do it the right way. And I promise it'll help you in the end. This is our answer, but notice that once again, we have this situation where we've created equivalent expressions, because even though we've changed the shape or the look of the equations, the value is exactly the same. We can't see that x equals 4 here as easily. I mean, you kind of can. But once we get it figured out, we can see, oh yeah, this means the very same thing, doesn't it? So this expression is true here, this equivalent expressions thing. And then this is the way we write the multiplicative property of equality, or we could say equations. I like that better. Equality just sounds hard. Equations. If A equals B, then A times C equals B times C. Make sense? So this is what we actually mean when we talk about that multiplicative property. And that is, if you've got an equation, you can multiply any number times both sides and it'll still be the same equation. All right? Just like here, we said you can add any number. All right? And this works if C is a fraction, and it works if C is a whole number. It works if C is positive. It works if C is negative. Okay? Yeah, that's all I want to say about that. Let's go on. I'm going to show you a slight complication that we sometimes get to. There's a total of 5 examples in this lesson, just so you know. What about this? 2/5 x equals 7. Okay, it's similar to this, right? We're multiplying, it's an equation. There's our x. We're multiplying something by x to get another number. Now, our logic up here would say, all right, we're multiplying by 2/5. So that means we should divide by 2/5. Are you gasping in horror? And it would look like that. I don't want to do that, you guys. I don't want to divide by a fraction. Dividing by fractions makes me feel like this. Death. I don't want to do that. I don't want to do that. So when we're multiplying by a fraction, we have a second strategy. I'm going to show you on the other side. This is what we do. Let me just recopy the problem. You don't have to. Instead of dividing by a fraction, we multiply by the reciprocal. Okay, so that's when we want to multiply by the reciprocal, is when we're trying to undo a multiplication with a fraction, and we don't want to divide by a fraction. Later we'll learn how to deal with that fraction over a fraction thing, but right now, heck no. Okay, so we're still following that multiplicative rule of equality because we're multiplying the same thing on both sides. That's a messy 5, sorry. This now, notice, these two go together. Whenever you multiply a number by its reciprocal, it turns into 1, right? 5 over 2 is 10, 2 over 5 is 10, 10 over 10 equals 1, and poof, it disappears, right? It's not our problem anymore. Yay. So now we have x by itself, and now we just have to clean up the fallout over here. This would be 35 over 2. That is our final answer. Did I? No, I didn't do this. I never feel right, you guys, if I don't put the little smiley face. Okay. So far, so good. So, fractions cause momentary drama, but we have tools to deal with them. Example 24.3. Here comes another one. Now I'm going to show you in the book. John puts a mixed number. You know how I feel about that. I'll copy it, but only because I'm a good sport. Equals 3. I don't want you to even copy it. I want you to change it. As soon as you see the mixed number in the problem, go, oh, heck no, I'm not dealing with that. And change it right away to an improper. 4 times 2 is 8, plus 1 more is 9. So this is 9/4 x equals 3. And now we have a problem like this. We don't want to divide by a fraction. A lot of times students will feel that little momentary panic of like, divide by a fraction, until they remembered, oh, right, I don't have to do that. I'm going to multiply both sides by 4/9. This goes to 1 and cancels. X is by itself. This, I can put over a 1. And then, before I multiply, I can see, oh, I can cancel right there. This becomes a 3, that becomes a 1, and so my answer is 4/3. Yay, that's the right answer. Make sense? Okay, we have 2 more. Example 24.4. Here we go. Solve x over 3 equals 9. All right. Oh, that's a weird looking 9, but just pretend with me. Here we are. We've got an equation. Here's our x. It's being divided by 3 is one way we can look at that. That's the easiest way, I think. So what's the opposite of division? Multiplication. So now we know we want to multiply it by 3 and multiply it by 3. Those cancel, and we get x equals 27. Okay, so sometimes we have problems that look like that. Make sense? And then here comes, oh, this is the last problem. X divided by, are you ready? 2.5 equals 7. Well, isn't that disgusting? I don't want any part of that. So it's still going to be ugly, but let's change that to 5 over 2. Notice that I exaggerate this fraction line because I want to make sure I know that this one is bigger than that one. I want to keep that really clear. Equals 7, all right? Now, I'm dividing by 5 over 2. So in this case, if I multiply by 5 over 2, Those will cancel. And so then over here I multiply by 5 over 2 as well. Hannah Cranny's happy. This is going to cancel. My x is by itself. X equals 35 over 2. Oh. And that's the right answer. This is technically one of those cheater problems where John gives you an A and a B. I do not know how he thinks he can get away with this. This is actually just the A, and I'm going to draw a little border wall here so I can do part B right there. I looked at the answer to this and I was like, I got it wrong? How could I have gotten that wrong? But it's because I looked at the answer to part B. Crisis averted, right? Okay, so here we go. P over 3/2 equals 4 1/3. All right, I don't like it. I'm going to rewrite it as P over 3/2 equals 13 over 3 over 1. That's how you can think of it. My lines are kind of, they aren't even with each other, but it's okay. Then I'll multiply this side by 3/2 and this side by 3/2. These guys cancel. P equals, and then those cancel, 13 over 2. Okay, so when we're dividing by a fraction, we don't have to worry about reciprocals. We can just go ahead and multiply by the fraction and we'll be fine. Makes sense? Here we multiplied by the denominator because that's like divided by. And then we did the same thing here. There it is on the bottom and we multiplied by it up top. Did that on the other side. Don't let the fractions scare you. You're not scared of fractions. You guys are way tougher than that. All right, lesson 24. Oh, I wanted to tell you one other thing. Lesson 23 and lesson 24 are often called the first and second rules of algebra. And they relate specifically to equations that you can add to both sides of an equation and you can multiply both sides of the equation. So that's rules number 1 and 2 of algebra. We're going to use them all the time. Okay, now I'm done. Goodbye.